Knowing the physical properties of fluids in our processes and equipment are critical to do any type of facility engineering calculation or analysis. We must use the properties of the natural gas and oil, hydrocarbon liquids, and produced water at operating conditions, not at standard conditions, as nearly all of the processes in our facilities are operated at elevated pressures. If we have the correct physical properties of our fluids, that will allow us to look inside the pipe or equipment and allow us to calculate critical parameters, such as fluid velocity, actual volumetric flow rate, etc. Correct physical properties are required to troubleshoot, size, and design any process piece of equipment or piping. Incorrect physical properties applied to these calculations will lead to incorrect results and conclusions. The business impact of not using the correct physical properties in equipment selection can result in selecting an inadequately sized separator, heater treater, or compressor, for example. This can result in loss in process efficiency and may have an impact on the amount of production that the facility can process due to inadequate actual capacity. On the other hand, there is also a risk that the facility is over-designed, resulting in excess capital expense due to purchasing equipment that is too large. Using the wrong physical properties when troubleshooting plant operating problems will likely not lead to the resolution or fix of the issue. This section of the core skill module introduces the concepts that underlie physical property correlations. Physical properties such as density and viscosity are important because they are used to size equipment. Density is used to calculate actual volumetric flow rates, which in turn is used to calculate velocities inside piping and vessels. Viscosity is an important property used for sizing piping, separators, mass transfer equipment, and heat exchangers. Phase behavior is important as it tells us the various operating conditions, whether our fluids will be in the vapor phase, liquid phase, or two-phase region. Qualitative phase behavior allows us to understand where the process is operating in relation to the fluid's phase envelope. Flash calculations are critical in process simulations as they will predict not how much vapor, how much liquid, and the composition of each stream. In addition to physical properties, thermodynamic property correlations allow the prediction of phase behavior and the calculation of energy changes in systems. These thermodynamic correlations require accurate prediction of fluid density, which is almost always provided by an equation of state. Equations of state will be discussed in more detail later in this section. Hydrocarbon analysis and C6+ characterization can be one of the biggest challenges in new field development. Adequate well stream sampling and analysis must be done to ensure that the phase behavior of the inlet fluids is well understood. If we do not have adequate sampling, or if the C6+ characterization is incorrect that is used for the facility design, the risk becomes that the facility may be undersized for liquids handling if the C6+ characterization is too light, or possibly much too large if the C6+ characterization is too heavy. An adequate extended analysis and reliable C6+ characterization parameters will ensure that the facility design for new field developments will be sized correctly for the fluid's composition and phase behavior. If we get the analysis wrong, the facility could be significantly oversized or undersized as a result. In addition, you may end up in the two-phase region where you were predicting only a vapor phase. That is particularly problematic as the system would not be designed to handle liquids in that case. The business impact of getting these wrong range from increased capital cost to lost production due to the inability of the facility to operate at design capacity rates due to inadequate liquid handling capacity. Or if the liquids are not there and the inlet fluids have a lighter composition, then the plant could be grossly oversized, an increase in capital investment with much smaller profit margins as the result of lower liquid recoveries. If acid-gas components are not analyzed for in the inlet fluids, then it may be possible that the produced fluids, which are water-wet, are more corrosive than the metallurgy of the plant was designed to safely handle. This could result in increased corrosion, increased operating costs due to needing to add corrosion inhibitor, or even piping and equipment replacement.